Look at this list of numbers. It's an ordered list of numbers, so it's a sequence. The first number is 3, the second is 0, third is -3, the fourth is -6, etc. It goes on. And there's actually a pattern here if you look closely. There's a number, and this special number, if you add it to any term in this sequence, you'll get the very next term. Now, just look at it. You can just inspect it and guess what that pattern recommends as being the difference between each of the terms that you would add. And so here I have it, the common difference. They call it common because it's the same number each time. You add it to any term, you'll always get the next term. That common difference between each term is a number -3. Now let me show you why. If you take the first term, 3, and you add -3, what do you get? The second term, 0. Okay, start with the second term, 0. Add the same number, -3, what do you get? -3, the third term. Okay, let's start with the third term, -3, and add this common difference, -3. -3 plus -3 is -6. Can you guess what the next term is going to be? Yes, -6 plus the common difference, -3, gives us -9. So you can generate the entire list knowing what this common difference is between them. The word common is emphasized because some sequences you can add a different number to a term and get the next term, then add a completely different number to that term to get the next. No, that's not the pattern we're looking for. An arithmetic sequence has the property that the difference between each of the terms gives you the same value. And that's why it's called a common difference. Let me show you how I find the common difference if I'm given a list of numbers like this. I'm told this is an arithmetic sequence. Let's talk about what the common difference is. Okay, I'll find the common difference. I'll take not the first term, but I'll take the second term, 0, and I'll subtract the number that came before it. That's going to give me the common difference. 0 minus the term that came before it, 3, equals -3. Okay, that should be a -3. 0 minus 3 equals a -3. Okay, let's do it again. Let's do the term -3 minus the term that came before it. So -3 minus the term that came before it. Now look at the list. Look at the list we started with. The term -3 minus the term that came before it. The term before it is 0. The answer is, again, -3. All right, let's try -6. Take -6 and subtract the term that came before it. If we get the same number that we've been getting, we know that this is arithmetic because it keeps giving us the same difference between the successive terms. That's the common difference. Sure enough, we get 6 minus the term before, -3. Double negative makes a positive, so it's -6 plus 3. That's -3. That is why the common difference D is equal to -3. Now, something else I want you to notice is that the pattern of what we've been doing here to show you where D came from, we're taking the nth term, A sub n, in the list, subtracting the term right before it, A sub n. And then we're seeing the value of that. If it keeps giving us the same value, then that is the common difference, and the sequence is arithmetic. So here is a list they gave us, 3, 0, -3, -6, etc. We recognize that it's arithmetic because we checked the difference between each of the terms that are showing, and it gives us a common difference, D. Okay, the other bit of information that's important to recognize in an arithmetic sequence is not just the common difference between the terms, but the value of the first term. We'll call that A sub 1. The arithmetic sequence, in this case, has the first term, A sub 1. We'll just look at the list. The first term listed is 3. So A sub 1 is equal to 3. And that's because A sub 1 is obviously the first term, 3. Okay, so if we were just given the fact that a sequence is arithmetic, well, if it's arithmetic, it has to have a common difference. Well, if we're given the common difference for a sequence and the first term, A sub 1, and the common difference, D. And they didn't tell us what the sequence was. Now, in this example, they gave us the sequence. Let's pretend we don't know what the sequence is at the top. Let's pretend they just said to us, there's an arithmetic sequence. The first term, A sub 1, is equal to the number 3, and the common difference, D, is equal to -3. Now, that is enough information for us to construct the entire sequence. Yes, because we know this property of arithmetic sequences. You just start with the first term and add D. Take that result, add D. Take that result, add D. And you keep getting successive terms. So let's make this list as if we don't know what it is. Start with the first term that they gave us. That's the number 3. A sub 1 is equal to 3. Now to that number 3, we're going to add the common difference, negative 3, to get our second term. 3 plus a negative 3. All right, that gives us our second term. We're going to simplify it in just a moment. But for the heck of it, let's do a sub 3. A sub 3 is the dude that came before him, which was, as you see here, 3 plus a negative 3. And then add the common difference. So here we go. The third term is the dude that came before him. There it is, 3 plus a negative 3. That's the guy that came right before a sub 3. And then add the common difference, negative 3. Okay, when we simplify it, we'll get a nice number. Now the fourth term is a dude that came before him, a sub 3, and then add the common difference, negative 3. So bracket this big mess that came before him, plus the common difference, negative 3, etc. Now, it looks pretty rough in that form. I wouldn't really write that if I were asked to answer this question. I would just say the first term is 3, the second term is 3 plus negative 3, which is 0. The next term is 0 plus the common difference, negative 3. The next term is, well, it's 0 plus negative 3 because that's a term that came before. And then, of course, add negative 3. But even better than that, I can do this whole thing in my head. I would probably answer the question if they gave me, they say, here's an arithmetic sequence. The first term is 3. The common difference, D, is negative 3. Make a list of the first 4 terms. I would do it this way. What I'm about to write is all I would need to write because I do it in my head. I'd say, okay, the first term is 3 plus add the common difference, negative 3 to that, you get 0. Now add negative 3 to that, you get negative 3. Now add the common difference, negative 3 to that number, you get negative 6. And if we wanted to list some more, the next one would be negative 6 plus a negative 3 is a negative 9. There's the list. So you don't have to do all that writing that I did. You can do a lot of that in your head. Okay, they also say they want us to find the nth term of the arithmetic sequence. The one that they gave us where the first term a sub 1 is equal to 3 and the common difference d is negative 3. Well, the good news is for arithmetic sequences we have a formula for the nth term. A sub n equals the first term a sub 1 times parenthesis, the index n minus 1, close your parenthesis and multiply that by the common difference. Now this is very convenient to have a formula for this type of sequence, but you can only use this formula for the nth term if your sequence is arithmetic. In other words, if it has a common difference. I'm emphasizing common. If the difference between every term is the same value, which we call D. All right, so this is an arithmetic sequence. It has a common difference. So we're going to go ahead and use it to find the formula for the nth term. Okay, so a sub n equals a sub 1 plus parenthesis n minus 1, close parenthesis, times d. That means that a sub n equals the first term, well, we saw that was the number 3, plus the index minus 1, n minus 1, times the common difference, d, which was negative 3. Now, this is the rough form of the answer. We need to simplify it. We just plugged in the values for a sub 1 and the value for the common difference, d. Simplifying that, we get 3 minus 3n plus 3 when we distribute multiplication by negative 3. And then that simplifies further to a sub n, the nth term, equals negative 3 times n plus 6. Now you'll notice that is not a recursion formula. That is just dependent. That formula for the nth term of this sequence depends only on the index n, right? You just multiply the index n by negative 3 and then add 6. So this is a really good introduction to the concept of arithmetic sequences.